So, for the first one there, we have ounces per square inch going into feet, pounds per square foot. So we're going to write this down as 2.8 ounces on top. Per square inch, we're going to put 1 square inch on bottom. Now I've got to change both units here. So I'm going to do the ounces first. Now ounces are on top, so I'm going to put them on bottom so they cancel out. What are we changing ounces into?
Pounds.
Pounds. So pounds go on top. What's the relationship between pounds and ounces?
1 pound is 16 ounces.
1 pound to 16 ounces. Very good. So the ounces have canceled out. Right now we've got pounds on top and square inches on bottom. So we're in pounds per square inch. We want pounds per square foot. So we're going to have to add on here. We got to get rid of the square inches. Right now square inches are on bottom, so to get rid of them we have to put them on
Bottom.
They're on bottom now, so to get rid of them we have to put it on top. And we're changing it to square feet. 1 square foot is how many square inches? 144. Squared, so it's 12 by 12. So square inches are gone, and we do now have pounds on top, square feet on bottom. So we've got 2.8 times 144, then we're going to divide it by 16. Oh, 25.2 pounds per square foot. Anybody come up with that? One? So now, kilograms per liter, in metric, we can actually convert each unit separately and then divide them out. So kilograms are becoming grams. Well, kilograms to grams is 3 spots to the right on the chart, so we move our decimal point 3 spots to the right. So it's 38,700. Liter, 1 liter is going into milliliters, or 1 liter is defined to be 1,000 milliliters. Or you could go 3 spots to the right on the chart. Divide that out, it's 38.7 grams per milliliter. If you knew that both units converted the same, you could. Just guessing that it's going to stay the same might not work out well for you. Just saying. 14 cubic feet per minute. And I want to change that into cubic inches per second. So I've got to change both the minutes and cubic feet. So I'm going to do the cubic feet first. 1 cubic foot is how many cubic inches? 1,728. There we go. So cubic feet are gone. We canceled them out. Now what else do we have to get rid of? Minutes. Minutes are on bottom, so we have to put them on top. We're changing them to minutes, go to seconds here. So 1 minute is 60 seconds. So this is going to be 14 times 1728 divided by 60. How do I know when to multiply or divide, by the way? Yeah. Perfect. If the number's on top, we multiply. If it's on bottom, we divide. So we have 403.2 cubic inches per second. So when you look at one like that, you would think cubic inches per second, it wouldn't be very many compared to the cubic feet per minute. But because a cubic inch is so small compared to a cubic foot, there's a lot of them. 14 cubic feet per minute, though, is a pretty standard pump, by the way. So 400 cubic inches per second would be pretty standard as well. So let's say you're taking a look at our 200 milliliters per second per 1 second. we have to change the seconds. So I'm going to do that first. Seconds on top, it's going to minutes. 1 minute is 60 seconds. So we got 200 times 60 is 12,000. That is now in milliliters per minute. But I don't want it in milliliters per minute. I want it in liters per minute. So now I'm going to convert the milliliters to liters, which is 12. So that's 12 liters in 1 minute. Any questions on that one? Okay, well, today we're going to talk a little bit about converting between metric and standard. But before we do that, we're going to talk a little bit about some weird units that come into play. Hertz. Well, your radio station might say 96.1 kilohertz or whatever for WDMC. Hertz is literally cycles per second. The power that comes out of your outlet is 60 hertz. That's 60 cycles per second. It's what we call alternating current. So it actually goes between pushing current out and pulling current back in. It's not just a constant flow of current in a single direction. There are advantages to that. But it cycles between pushing and pulling 60 times per second. That's the way most of your modern clocks work, by the way. Your old clocks used to have a lot of mechanical pieces in them that forced them to move, 1 tick per second. Well, most of your clocks now that plug in are actually going off the frequency of your power of every 60 cycles they click ahead 1 second. The abbreviation for hertz is capital H, little z. If I tell you something is operating at 2 kilohertz, what does that mean? What's the K mean? Kilo means 1,000. So that means that it's operating at 2,000 hertz. Or here's one that Anthea should know about. .8, the capital M and then the HZ. What's the M stand for? Mega. So 3.8 megahertz. How many hertz is that? Do you remember what mega stands for? Mega is million. Just guessing you've had some megahertz in your life. Well, there you go. Now for hertz, we don't often go below 1. We usually don't run into the millihertz or anything like that. But we will when we get into, if we talk a little bit more about electricity in the next class, you'll talk about milliamps, microamps, and stuff like that. If we were talking about capacitors and inductors, which we're not going to in here, did you guys in your electronics even get into capacitors? For cars, for automotive? A little bit. So for capacitors, what's your units for capacitance?
You expect me to remember?
Come on.
God, that was like a month ago.
Capacitance is a Henry. Henry's an inductor. A Henry is an inductor. What's your unit of capacitance?
No, I don't know. I don't think we ever learned that.
A farad?
I don't remember that.
Most conductors will be usually in the microfarads, like
Yeah, no, we never.
23 microfarads. You just went over what a capacitor is and how it works. Okay, yeah. A farad is a unit of capacitance. What a capacitor is let's say you have a circuit. That's your power source, whether it's a battery or whatever. Then usually you have like a resistor that it flows through. And so that battery will push current through the circuit. What a capacitor does, just in a simple circuit, would look like this. It's basically two flat plates. So this battery will push current, but obviously it can't go through those two flat plates. They're just spaced apart. What happens is charges build up on this side. Let's say negative charges build up here. Then it pulls charges this way, and positive charges build up on this side. So you have that potential between those two plates. The only reason the negative charges stay here and the positive charges stay here is because the battery is forcing them to stay there. You unhook it from the battery, they have no place to go. So you can take that capacitor and hook it into another circuit, and it'll discharge. It'll work as a battery for a very, very short period of time. Where a capacitor is used in most things, and it's used on agricultural control panels and stuff like that, is to deal with power surges. Instead of just being hooked up in the middle of a circuit like that, it's often hooked up like this, where this is what you're trying to operate, and then you have a capacitor right here. So let's say this is a 120 volt system. You have the charges built up on the capacitor here. But then you still have electricity flowing through this. So if you have a power surge or a power dip, let's say you have like a sudden dip in power. Well, if this voltage falls below 120 volts, this capacitor will discharge, and there'll still be a small dip in power, but the capacitor will discharge to compensate slightly, so whatever's going through this that you're trying to operate doesn't dip quite as much. Same with a power surge. There's a power surge, and all of a sudden this shoots up to like 150 volts or whatever. Well, technically it cycles between negative 170 and positive 170 anyway. But 120 is just an average voltage. But as you say, you get a power spike where it goes way up above where it's supposed to be. A lot of that voltage will build up on the capacitor rather than surging through here. I said a small amount will surge through this, but not near as much of it as it would normally. So a capacitor is used to even out power and to avoid power surges. There are certain things in a car where a capacitor is used to give a boost of power. Some cars required a capacitor for their starter to work because the actual battery themselves didn't have enough power to operate the starters. Also used a lot in the electronics now in the newer cars. What did you guys discuss as far as where they were used in applications in a car? Or just discussed what they were? Okay. For the most part, they're used under the dash to avoid surges and stuff like that. Okay. Now we're going to talk about converting our metric units to standard units. And back again. To do this, we have to have an equivalency. And that little sheet I gave you with all the conversions on it has a lot more equivalencies than what I'm about to give you. Because I'm only going to talk about one equivalency in each type of measurement. So we're going to start out with length. In length measurement, the only equivalency that I have memorized, that I use, is that 1 inch is 2.54 centimeters. There's all sorts of other ones out there, like 1 meter is 1.1 yards, or 1 meter is 39.37 inches, and all sorts of things like that. 1 meter, I think, is listed as 3.25 or 3.3 feet. There's a bunch of them, like I said, on that conversion sheet I gave you. This one I use because it's the most accurate. Even this one is approximate. It's slightly rounded off, but it is the least rounded of any of them. Like, especially the 1 meter is 1.1 yard. That's way rounded off. But
She says 1 yard is 0.914.
Should go both directions. Should have 1 yard equals 0.914, and then 1 meter equals 1 point.
Where do you see that? I don't know.
And realistically, the only conversion I need is that 1 inch is 2.54 meters. So let's say I have something. Let's say you're told that a person is 180 centimeters tall. Is that person tall, short? Let's take a peek. 180 centimeters. Put it over 1. Centimeters on bottom, inches on top. 1 inch is 2.54. So what's this telling us to do? 180 divided by 2.54. 70.87 inches. So that person's about 5'10" 7/8. But what if you have something that is 10 feet long? Do I know how many meters long it is? Well, first thing we would have to do, if we're going to use that 1 inch is 2.54 centimeters, I'd have to convert my 10 feet into inches. 10 feet is how many inches? Times 12, right? Gives 120 inches. Now I'm going to convert my 120 inches into centimeters. 1 inch is 2.54 centimeters. What are we going to do in this conversion? 120 times 2.54 is what? 3,048, I believe, centimeters. Does that look right? Now, of course, we don't want this. No, 304.8 is centimeters. We don't want this as centimeters. We want it as meters. How many meters is that going to be? 2.048. Look right? Because you get from centimeters to meters, you're moving 2 spots to the left. So with that one equivalency, 1 inch equals 2.54 centimeters, we can do all of the metric to standard length conversions we need. Now, if it's volume, let's say that we have something that is listed as 200 cubic centimeters. I want to figure out how many cubic inches that is. If you recall, when we were talking about our cubic inches to cubic feet, we had to take our length and we had to cube it. It was 12 inches in a foot, but if it's cubic feet, it was 12 by 12 by 12. Same thing happens here. We've got 200 cubic centimeters over 1. We're going to get rid of cubic centimeters and go into cubic inches. Which one's bigger, an inch or centimeter? Inch. So the 1 goes there. There's 2.54 centimeters in 1 inch. So what we have to do is we have to cube that to the power of 3. We're cubing our conversion factor. Well, 1 cubed is just 1. 2.54 to the power of 3. Is 16.387. Centimeters cubed and inches cubed. So on the bottom of this, we put 16.387. So what this is telling us to do is take 200 divided by 16.387. Now I'm actually using the whole 0.387064 here. So I mean 12.205 cubic inches. Does that make sense? So 200 cubic centimeters is 12.205 cubic inches. So let's put this in terms of something you guys might be a little more interested in. 5.7 liter motor. What is that in cubic inches of displacement? 350 is what we're used to, right? It's not an exact conversion, though. 5.7 liters. The first thing we would have to do is convert it into milliliters. 5,700 milliliters, right? From liters to milliliters is 3 spots to the right. How many cubic centimeters would that be? 1 milliliter is how many cubic centimeters? 1. A milliliter and a cubic centimeter are the same thing. A milliliter is defined to be a cubic centimeter. So now we're in cubic centimeters. We're going to do the same thing. We're going to convert our cubic centimeters into cubic inches. 1 cubic inch is 16.387 cubic centimeters. So we're going to take 5,700 divided by 16.387. 347.84 cubic inches. So it's technically not quite a 350.
Why do you use it as a 360?
They're just throwing it. I mean, it's a round off is what it is. Technically, that's probably a 5.68 liter, but they always round it off the nearest tenth of a liter.
That sounds like it really is.
Yeah, so it might be a 5.65 liter, but they're rounding it to 5.7. Could be a 5.74 and they're rounding it to a 5.7. Let's look from the other side. The Ford 302, that's 302 cubic inches, is considered to be a 5.0. Well, let's look at what it really is. So now we're putting cubic inches on bottom, cubic centimeters on top. 1 cubic inch is 16.387, right? 387. What's that?
I'm looking on a different sheet.
So 302 times 16.387 gives us 4948.87. Now that is cubic centimeters. It is also milliliters. So to convert that into liters, we got to move 3 spots to the left. That's technically a 4.949 liters quarter. But they rounded off to a 5.0.
So,
What's that? Yeah. Even that's rounded incorrectly. They just always round it up. The reason they rounded it that way, by the way, is a 305. You know, the Chevy, basically the Chevy equivalent, is like a 4.951. So that does round up to 5.0. So they just called the 3.302 a 5.0 so that they look the same size. Oh, you do? Just read one off and you know the other one? That's no fun.
Hey.
So, I've got a 3.0 liter. What's the cubic inches?
3.0.
Yep.
Which one do you want? 181, 182, or 183?
It really doesn't matter. But as you can see there, it lists there's several different capacities in cubic inches. It's the same thing because they all round off to 3.0.
And then there's an easier math equation in here too.
This just got the equation. You put the number in and it runs it out for you. What's the equation they give you?
Cubic inches divided by 61.02.
61.02?
And that would be what liters equal.
You know where the 61.02 comes from?
My book.
This number I had here, the 6.387 or 16.387. Take 1,000 divided by 16.387. There it is, 61.02. So I don't know why they'd have you dividing by 61.02. I would have had you multiplying by 0.01639 is what I would have done. To me, it's easier to multiply than it is to divide. I'm guessing what they're doing is going the other way from cubic from milliliters into cubic inches. They're multiplying by the 61.02. So they just wanted to keep the number the same. You multiply one way, divide the other way.
Yeah, the easy way.
Sure. That works. You feel free to use that table.
Well, I'm going
Okay.
to. My pen. Huh? I don't know where to put my foot.
Everybody's trying to get the page number out of your other book.
I don't know,
For capacity, the equivalency that I have memorized is that 1 gallon equals 3.785 liters. So let's say your gas tank, you have an 18-gallon tank. Let's say we finally switch over to the metric system. How many liters are you going to be filling up with? Well, 1 gallon, 3.785 liters here. The gallons cancel out. It'll be 18 times 3.785. $68.13 liters. So your 18-gallon tank now becomes a 68-liter tank. Let's look at the other side of it. If we switch to the metric system. Right now, what is it, about 215 a gallon? 219? So we're going to go 215 per 1 gallon. If we switched over to the metric, of course, now we're going to have to figure out per liter, right? So gallons on top, liters on bottom. 1 gallon is 3.785 liters. Does the table I gave you, does the piece of paper I gave you, does that say 3.785 or just 3.79? 3.75, good. So this is $2.15 divided by 3.785. 57 cents a liter. Doesn't make it feel like it was a lot cheaper, right? They're never going to let you get away with paying 57 cents a liter anyway. When we go to Europe, most countries in Europe, gas is about $1.40 a liter. If you put it in equivalent your currency. So $1.40 per liter. For 1 liter. Liters on top, gallons on bottom. 1 liter is 3.785 gallons. Liters are gone. We're going to do 140 times 3.785. $5.30 a gallon. That's getting pretty pricey. Yeah, but they also have a much better developed mass transit system, where you can get pretty much wherever you want to go without owning a car. Let's say your car consumes, say your car's getting 24 miles to the gallon. That'd be nice.
I got 8.9.
Ouch. I'm guessing a truck.
94 Chevy, small block 350.
Let's figure out how much that is in kilometers per liter. What would your equivalent mileage be? So we'll set this up. 24 miles over 1 gallon. Now we've done our conversion on miles. On your cheat sheet, what's the conversion given for miles to kilometers? Does it give one?
1.609.
1.61, we'll say, kilometers per 1 mile. Then our gallons. 1 gallon is 3.785 liters. So we got rid of the gallons. We're now in kilometers per liter. So this is 24 times 1.61 divided by 3.785. So you're getting 10.2 kilometers per liter. Now, if you do that, you said you're getting what, 8.9? You said. Let's call it 9. Make it easy on us. You're 9 miles per gallon. I'm just gonna do this the easy way. Is it slipping? So it's got over rev.
Well, and it don't shift until 32 or 33 in the direction that it
Oof.
don't shift into the next gear.
Can't you play with the gas pedal and force it to shift? No, it won't do it.
Okay.
That sucks. Even if you shift it up through first and second manually and then
Well, then it'll
pop it into drive.
but
When you pop it into drive, though, does it kick up or does it? It will. So you've got to play with it. So your 9 miles to the gallon is 3.8 kilometers per liter. Sounds even worse there, doesn't it?
sounds like I'm driving.
Okay, next we're going to talk about weight. Now we had talked about this at length back when we did our weight in unit and mass units. But in the standard system, our pounds are a unit of weight. In our metric system, our grams are a unit of mass. But because we're on Earth and gravity is relatively constant, we kind of use them interchangeably. So when we do our conversions from metric to standard, we get a little sloppy here, and we convert weight into mass, even though technically they're not equivalent. A kilogram is bigger than a pound. Technically, it's like 2.208, but we just use 2.2 pounds per kilogram. So let's say you weigh 220 pounds. Pounds.
Your sheet says 1 pound equals 0.45 kilograms.
Yeah, it's going the other direction. So we're going to put pounds on bottom, kilograms on top. 1 kilogram is 2.2 pounds. So all this is telling us to do is take that 220 divided by 2.2. That's 100 kilograms. Now, if we use what was on that sheet, would it make a difference? Well, let's take a look. 220 pounds, and put it over 1. That says 1 pound is what, 0.4? 0.4536 kilograms. If I took 1 divided by 2.2, I'm going to get about 0.45. But anyway, this would be 220 times 0.4536. I get 99.79 kilograms. So you can see it's just a matter of round off. We're within like 21 hundredths of a kilogram. So let's say that we have 16-gallon tank in our car. We're going to make an assumption here that gas weighs the same as water. Now I realize gas is actually slightly lighter than water. But just to make this calculation easy, we're going to assume gas is the same as water. So 16 gallons. How many kilograms is that going to be? I have to specify of, we're going to say water, just to be accurate. Well, first thing I got to do is I got to change my 16 gallons into liters. Once it's in liters, I have to change it into milliliters. Actually, we've known from our conversion that 1 milliliter equals 1 gram of water, 1 liter equals 1 kilogram of water. So if I just change it into liters, we've got the kilograms, right? So 16 times 3.785. We get 60.56 liters. Let's go through the process. So that is 60,560 milliliters, which is 60,560 grams, which is 60.56 kilograms. So 1 liter does come out to be 1 kilogram. So that 16-gallon tank is going to add 60 kilograms of mass to your car. Okay, so today we're going to finish off that packet. In that packet on page 238, problems 65 through 75 do metric to standard, actually standard to metric. And on page 266 of that packet, problems 63 through 90 do metric to standard. Tomorrow we're going to talk about time and temperature and a little bit of electrical units again. And that'll wrap up unit 3. So that means on Thursday will be unit 3 test for you guys.